So let me pick up on the next part. We're still dealing with logical operators right now with it, and we just finished. This is all the AND operators in here with it. So one of the things I want to talk to you about is this is why do we have these operators and all the stuff with it as well, because again we're getting down to the itty-bitty details of this. The second set of logical operators, we have the first one is the not equal, the second one is the equal, I'm sorry, the and, ampersand, which is the and the third set is the or, which is represented by the pipes, the vertical lines with it. And I share with you, if you have these vertical lines, they're called pipes in Unix. That's what that is with it. If you look at your shift backspace line, backspace key, that's the one that's right above your backspace with it. It's on the right hand side above your key, your enter keyboard with it. So what does this do with it? So let me share with you on a couple of stuff that's going on with this right here. So again, I'm going to do the expression that we have over here with it. Let me take this over here to this side over here. So let's say we do the expression. Let me do this expression over here. I'm going to do expression number 1, and then we have expression number 2, and then I'm going to have a column that says outcome over here. So over here, when we come over here, and in between them, we're going to have the OR symbol with it. And what's important is what's the outcome? What is both of these evaluates to? If the first expression is true and the second expression is true, all right, you get a true outcome, right? If your first expression is true and your second expression is false, okay, you get a true outcome over here with it. So if your your third, I'm going to come down to the next circumstance over here with it, is if you take your expression, I lost my mouse here. So if this first expression is false, right, and my second expression is true with it, I get a true outcome. And if last one is if you get a false here, and if this is a false, of course this outcome would be a false. Okay, so why is this so important in this? And I'll tell you, expression or could be some sort of mathematical calculations that you put on each side of these things. And what's important is the Boolean expressions are these columns over here. This is what's important is this one right here. All right. Now again, I'm going to talk to you. I want to point out some stuff that you need to see with it. Is if you look at your first expression, is if it's true, and your second expression is true, you get a true. But if you look at expression 1, if it's true, is there a need to evaluate the second one at all? Okay. So we call this short circuit. It just helps the processor process a lot of things if you design your code properly with it as well. So just put that seed in your mind with it, is once if this is true and this is true, all right, because your first expression is true, there's no need to actually look at your second expression in an OR statement. We call that a short circuit. All right. So that's a very important concept to understand with it. Of course, the next part of the chapter is it talks to you about the order of precedence with it, and this is very important for you to look at. Is the table 4-, and the only way I could tell you order of precedence is we're all familiar with expression in chapter 2 is please excuse my dear Aunt Sally with it, right? So parentheses, exponents, and all the stuff that we talked about with it. But how does that really apply to what we do? This is table 4-6 with this as well. So if you let me click over here. I want to just turn your attention to table 74-6. This is on page 202. All right. So when you have what's first, what is second, what's called a unary operator, the closest to the number, that's the first thing with it, right? So go down that list. I'm not going to go down that table with you as well with it, but just make note that there are some higher precedence with it. For example, the equal has higher precedence than the and the or. The not has a higher precedence than the ands and the or. But what's more important, whenever you are, and this is across the board with it, is whenever you look at this, all the way down to the last one is the sign operator, the single operator one with it. And all I can tell you here is just you have to memorize this. That's all I can tell you. All right. So, and there's also what's called the associative rules, just to do from the left to right with it. So we'll do some examples of this for you to see. We'll do some examples out of this thing so you can see what's going on with this. Okay. So here's what I'm going to do. So let me pull up some of the pull up some of the exercise in the back of the book, and we'll do some exercise together with it. All right. Hold on. So what I have done is I pulled up, this is chapter 4 in the back of your book with it, and there is this, I'm going to do number 2 with you. All right, this is, I believe, on page, let's see, I don't know what page this is under. This is on page 246. All right, so let me pull back that canvas that we were looking at. I'm just going to kind of place underneath here so you can see what I'm trying to do here. So let's say you have this expression up here, and you have something that's 4, multiply that with 7, and it's asking you with this 74 divided into 3. All right, so let's just kind of play with these numbers for us to see with it, right? So 4 times 7 is what? 28. Asking you, does that equal to this side? So what is 74 divided into 3? I don't know about you, but I gotta do long math in this thing. So I want to come over here just a little bit about over here. Let me see if I can actually get some scratch. So I gotta do like 74. I don't have a calculator on hand here. So 3 goes into 74 how many times? 2. So this becomes 6. Subtract that, becomes 1, and 3 goes into 14 how many times? Let's say 4, and that becomes 12, right? And that's 2, right? So this has kind of like a remainder of 2 in here. But I'm interested in this part because it's 24, because 74 is an int, 3 is an int into an int gives you a int, right? So this answer down here at the bottom is, put 24 here. 28, is that equal to 24? Remember now, this is equal. This is the question mark, and you should get a what? You should get a false, right? A false is equivalent to is a 0, right? So a return, if you output this, do a cout, and you put this expression on there, you're going to get an output as the 0. All right, and that's how that works with it. So that's why I want to show you is a couple of those mathematical expression that you kind of do with this as well. Let's try some more. I want to try some more with you with it, just to give you in the right track with this. And let's try that next one with it. So let's say you do that 4 plus 7 divided into 2 less than or equal to 9 minus 15 mod 6. All right, I want you to take a second, pause my video. I want you to work through this at this time, and then we're going to come back and compare notes. All right, I want you to do that. So just stop this video right here for me, pause it, and then I want to pick up where we left off in a second. Okay, So let's come back and regroup here. I want for us to look at this expression that you're looking at right now with it, right? So let's say you're coming down here. So again, when you look at this, you have to look at the order of precedence in here. And some of you are not familiar with mod and the percent with it. You should pick this up in a chapter, in the earlier chapter with it, in chapter 2, what's mod. So when you look at a percent, which is a remainder, right? And what's 15 mod percent? 6 means what? So it's basically 2 times 6 equals 12, and you take the difference between 15 and 12 is 3. So this answer, all of this comes out to the bottom line is 3, and you take this 9, you subtract 3 is what? 9 subtract 3 equals 6, right? And still, you carry down this expression down here, and this left-hand side over here, 7 is an int, 2 is an int. So how many times does 2 go into 7? 3 times with it. So it becomes 4 plus 3, and that answer is 7. The answer is 7 less than or equal to 6. That's the question. And the outcome for this should be what? Is a false, and you should get an answer that is an output that which is a 0. All right. So that's the type of stuff that I need for you to actually practice and work on right now with it. All right. Another note I want to bring your attention to mod is this. So some of you, if you're uncomfortable with mod, let me show you how to do this. So what would the answer be if I have 6 mod 15? What does that equal? Well, here's my rule of thumb on mod. If you take the first digit, if it's smaller than the second digit, you just move that digit over here. So 6 mod 15 is what? It's a 6. So if I did like, what's 2 mod 7? Again, first digit is smaller than second digit, and that would be 2. Now, on the other hand, if I ask you, what is 7 mod 2, what does that equal? Well, it would be 1, because how many times does 2 go into 7? Is what? Again, 7 is larger than the second one. So if 3 goes into 3 times 2 is 6, and you have a remainder of 1. See how that works with it? You know this, but you just kind of forgot how a lot of these things just needs a little friendly reminder with it as well. Alright, so just practice this on your own for me, okay? So just to give you a few problems and how things work with it. Again, when you come down to, let me do another one for you. Let me move down to this one, alright? So you have an uppercase K. What is an uppercase K? It's a char. Make sure you put your apostrophe less than a lowercase k. What is that? Okay, this is a single quote with it. So you look up the uppercase K. There's a couple of ways you can do this. If you look at your appendix or the table in your book with it, I guess it's the beginning of your chapter. This is on page 190, or the ASCII value in the back with it. So if you went and you look at uppercase K, I have it's number 75. All right, for uppercase K. So I'm just going to come down here. I'm going to put 75. Is that less than the lowercase k, which is 107? Alright, so this is what? True. Right? This is true. This is true. So that's all you do. So, you know, go through this one by one and kind of play with this and kind of understand how this works with it as well. Again, let me do another one for you. Like a lot of the stuff you can work through on here as well with it. But let me stop the video because I'm approaching almost 15 minutes on this video. Hold on.